Hello students, good afternoon. So we are in the third session of the electrostatic potential and capacitor topic. Already in session 2 we are looking at the concept of electric potential dana. So session 2 we talked about how do we define electric potential, okay, and how do we measure electric potential at a location. Adukapram we have looked at what is the way to find out the work done in moving a charge. How do we find the work done in moving a charge from one place to other place? Okay, so this will be related to what? The work done expression will be related to the potential, or we say potential difference. Okay, so all these we have covered. In Canada, we will start with the relation between electric potential and electric field. And past year questions they have asked questions on relation between the electric potential and electric field. Okay, so first we will see what is the similarity between electric potential concept and electric field concept. Okay, already now our point the electric field as well as electric potential, both are what? Space functions. Okay, space function and so because they will be defined at a point in space. Charge that does not matter. The electric field as well as potential, right, will define it in the space. That is why we call them as what? Space functions. Okay, now similarity in if you look at a charge q, or a charge q at that time place then this charge will interact with the electric field at that location, and the location electric field interact that will give rise to what? The electrostatic force. What is the force acting on the charged particle? Q times of E. Okay, so we have the interaction between the charge and the field that is giving rise to what? Electrostatic force. And if you look at what is the electric potential V at the location, the interaction between the charge and the potential, right, Q times V, that will give us what? Potential energy. So potential energy of the charge at the location is equal to what? And the particle of the charge multiplied by the electric potential at the location. So every field could interact with charge is getting the force, and the charge interacting with the electric potential, right, will give rise to what? Potential energy. So in the particular expression whatever the role that the field is playing, Q times of E is what? Force. Same role electric potential is playing, Q times of V is what? Potential energy. Okay, so நம்ம அந்த force ஒரு charge particle மேல force எப்படி வருதுன்னு பார்த்தா அது எப்படி the interaction between the charge and the field is giving rise to force. அந்த மாதிரி for a charged particle, right, how it is getting that potential energy by staying at a location எப்படி வருது? If the charged particle is interacting with the potential at the location, and the interaction it is gaining the potential energy. Okay, so this is how we will see the similarity between the electric field and electric potential. Both are what? Space functions. Similarity mattum kediyadu, we also have some differences. So basically சொல்றதுக்கு என்ன தெரியுமா? The field is a vector quantity, but potential is a scalar. Their units also will be different, and their dimensional formulas also will be different. Okay, but here we are trying to understand what is the relation between the electric field and potential, and the rendu nadu what is the relation between them. So adha nam indha session la paaka porom. Adukku enna theriyuma? We will start with a test charge. Or let us keep a test charge q. Okay, so what is this small q? Idanadu or test charge. Okay, ipo indha edathila let's say the electric field or E bar vechkonga. What is the electric field? E. So what will be the electrostatic force acting on the charged particle? Q into E bar dana. What is the electrostatic force? Q into E bar. Okay. Sorry, in the we'll just give the particle some small displacement. dr bar and சொன்னேன்னு தெரியுமா? It's a very small displacement. Okay, it may be in the direction of the electric field or it may be in some other direction. அதனால என்ன தெரியுமா? We are keeping it some orientation. So இப்போ இந்த ரெண்டுத்துக்கு நடுவுல the angle we are considering it to be theta. Okay, so theta is what? The angle between E bar and dr bar. And the ரெண்டு directions நடுவுல இருக்கிற angle is what? Theta. Okay, so இப்போ பாருங்க, for this small displacement, right, what is the work done by the electrostatic force? What is the work done by the electrostatic force? Another, it will be force dot displacement dana. What is the work done by the electrostatic force? Force dot displacement, which means what? Q into E into dr into cos theta. Dot product E vector and dr vector, and the ரெண்டுத்துக்கு நடுவுல dot product, right? What is that? E magnitude dr vector magnitude multiplied by cos theta. Okay, so this is what work done by the electrostatic force. But remember, nam already potential energy oda definition, change in potential energy will be equal to what? Negative of work done by the conservative force. Adana potential energy or definition eppadi? When we look at any conservative force like electrostatic force and the madri, the negative of work done by the conservative force is what? Change in potential energy. Okay, ipo parunga, this change will not be significant. It's a very small change. Okay, ipo initially charging irukka, let us say the potential at the location is what? Vn vechukonga, and potential at the நம்ம கொஞ்சம் displacement கொடுத்திருக்கும். The potential at that final point is V plus dV. Small change is coming. Okay, so இங்க என்னது? The change in potential is a very small value. So இப்ப பாருங்க, the change in potential energy, that is also small value. It will be what? Final potential energy minus initial potential energy. இது என்ன வரும் பாருங்க? QV plus QdV minus QV. So QV cancel ஆயிடும். What is it? QdV. Change in potential energy value என்னது? It will be Q times dV. So இப்போ நம்ம என்ன போறோம்? அப்படியே அந்த ரிலேஷன் நம்ம சப்ஸ்டிட்யூட் பண்ண போறோம். என்னது? Change in potential energy for a conservative force, right? Negative of work done, which means minus QE dr cos theta is equal to what? Change in potential energy. அதோட வேல்யூ என்ன? Q dV. So இதல Q cancel ஆயிடும். Q and Q will be getting cancelled. Okay, so இப்ப பாருங்க, what is the expression we have? Minus E cos theta is equal to dV by dr. இதுல இருந்து we'll get E cos theta is equal to minus dV by dr. Such an important result. என்னது? E cos theta. E cos theta is equal to what? Minus dV by dr. இதுல இருந்து I'll tell you what is the significance of this particular relation. First, இந்த relation நமக்கு புரியணும் எப்படி வருதுன்னு சொல்லிட்டு. What is the relation? E cos theta ஓட value, right, will be equal to what? Minus dV by dr. இப்போ நம்ம இந்த expression ஓட significance பார்க்கலாம். See, in the same diagram, right, அப்படியே நம்ம கொஞ்சம் maximize பண்ணி இங்க represent பண்ணலாம். Let's say we are having the charge Q. Electric field is in this direction. Okay, we are giving a displacement dr at an angle theta. So in a certain direction we are giving a displacement of dr. Okay, in that direction what is the change in potential dV? Okay, dV by dr இது என்ன தெரியுமா? The small change in potential divided by the distance moved along the direction. Small change in the potential divided by distance moved along the direction. So idukanna we have a technical word. We will call it as gradient of potential along that direction. So gradient nu sonna theriyuma? It is we have the change in potential. So for example, we are moving in a direction vechkonga, and the direction la we will see what is the potential change, divide that by the distance moved along the direction. So adukku nama enna use pananum, technical term gradient. Okay, so same in the gradient word 3p we will have in the properties of fluid chapter liyum varum when we are defining the viscosity. Okay, so the formula பாருங்க minus dv by dr irukka, means minus dv by dr means we will say negative of gradient. edukku negative நம்ம வருது word, because it is minus dv by dr. So minus dv by dr is what? Negative of potential gradient in a direction. Negative of potential gradient in a direction. என்ன தெரியுமா? Potential gradient will be having what units? SI unit of potential gradient will be what? Volt per meter. SI unit of potential gradient will be what? Volt per meter. பாருங்க, negative of potential gradient in a direction. இப்போ நம்ம எடுத்த direction என்னது? The direction along the dr bar. அதுதானா? Negative of potential gradient in a direction will be equal to, what is equal to? E cos theta. E cos theta என்ன தெரியுமா? இப்போ பாருங்க, E is like this. It is making an angle theta with the direction of the displacement. இப்போ E cos theta என்ன தெரியுமா? What is this E cos theta? Component of that electric field, and the electric field component in that particular direction. So negative of potential gradient in any direction will be equal to what? It will be equal to what? Component of the E bar along that direction. So on the direction la, whatever is the electric field component, right, that will be obtained by using what? Negative of potential gradient. Okay, so இப்போ இதிலிருந்து we will get one simple conclusion. என்ன தெரியுமா? If we are at a particular location வச்சுக்கோங்க, okay, we are at a location, we don't know in which direction the electric field is. We don't know what is the direction of the electric field. அப்ப என்ன தெரியுமா? Randomly we will choose some 3-4 different directions. அப்படியே அந்த பாயிண்ட்ல இருந்து we will try to mark some 3-4 different directions. அது எப்படி என்ன? Let's say we are marking a point. Okay, so we will mark path 1, அந்த மாதிரி path 2, path 3, path 4, like that. Now in whichever direction the potential gradient is more negative, the potential gradient value is what? More negative, then on the direction la the electric field component value will be higher. இப்போ பாருங்க, இந்த expression பாருங்க, E cos theta is என்னது? The component of the electric field in the direction. It is equal to what? Minus potential gradient in the direction, right? இப்போ potential gradient is more negative means what? Minus into minus becomes plus. Okay, so because of that the component of that electric field in the direction will be becoming higher, which means the conclusion is like this, simple. In whichever direction the potential gradient is more negative, in whichever direction the potential gradient is more negative, adalende what is the conclusion we can derive? In that direction the electric field component will be more. In that direction the electric field component will be more. Okay, so in the மாதிரி analysis எல்லாம் என்ன தெரியுமா? This will be useful for us while solving questions in the competitive examinations, especially NEET la பார்த்தீங்கன்னா we will get these kind of reasoning questions and சொல்லலாம், or the analysis questions. இப்போ பாருங்க, when we get the highest value for this minus dv by dr, when the minus dv by dr value, whenever it becomes highest, which means what? The dv by dr value is highest negative. That will be highest negative வச்சுக்கோங்க ஒரு directionல, which means what? That will be the direction of our electric field. அப்படிதானா? Like whichever direction. இப்போ பாருங்க, E cos theta. What is the E cos theta maximum value? When cos theta is equal to 1. which means theta is equal to 0. அப்படிதானா? When cos theta is equal to 1 means theta is equal to 0, which means what? When theta is equal to 0, that is when the E cos theta will have the maximum value, which is our E. அதுதானா? In that case, what we'll have? E is equal to minus dv by dr. Otherwise, minus E is equal to what? dv by dr. So we'll have what? The potential gradient to be highest negative when we move exactly in the direction of the electric field. Okay, so this is what is the conclusion that we'll have by analyzing that in the gradient relation. Okay, so this can be a sample type of question. From a point in space, the potential gradient along 4 paths, space they have marked a point. Okay, angalende they are calculating what is the potential gradient along 4 different paths. Path A, what is the value? Minus 60 volt per meter. So அப்படியே நம்ம மார்க் பண்ணலாம். Path A, what is it? Minus 60 volt per meter. Path B, what is the value? 120 volt per meter. Okay, அப்புறம் path C, what is the value? Minus 135 volt per meter. அதுக்கப்புறம் path D, what is the path D oda value? 100 volt per meter. Let us see what they are asking. அவங்க என்ன கேக்குறாங்க? In which path the electric field is likely to exist? So remember the same concept, right? Oh, any direction we are calculating the potential gradient. So நம்ம கிட்ட இருக்கிற ஃபார்முலா என்ன? E cos theta is equal to minus dv by dr தானா? So அதுல dv by dr is what? Minus E cos theta. dv by dr is what? Minus E cos theta, which means what? If the potential gradient, whichever direction is highest negative, then it means what? The component of the electric field in the direction will be higher. So inga parunga, if we look at the 4 given paths, right, in which case the potential gradient is highest negative, we should also see the sign value. It's not about just the numerical value mattum kadiyadu, we should also look at the sign. Inga parunga, path C, right, adula what is the potential gradient? Minus 135 volt per meter. It is highest negative. Adha nama paakanum. Okay, so in that direction, what we can clearly say is, in path C, what we can clearly say is what? The component of that electric field is maximum. Adha nama clear ah sollala. What we can say, because whichever direction the potential gradient is more negative, and the particular direction enna varum? The component of that electric field will be maximum. But here they are not asking that. They are asking what? In which path the electric field is likely to exist. They are not saying exactly tell in which direction the electric field exists. Endha idhila it can be likely existing. Adha kekranga. So which means among the given ones, what do we have? The component of the electric field is maximum in the path C oda direction la. So what we'll say is the electric field also can likely exist in the path C. What we'll have to say? The electric field can likely exist in the path C. What we can say for surely is that the electric field or the component along the path C will be maximum. Adha nama correct ah sollala. Adilundu they are asking us to comment what is the likely path. Inga irukra options enna? Definitely it cannot be A. B kadayadu, C kadayadu, I mean D kadayadu. Then what is the only alternative? Since the electric field or the component is maximum in the path C, we will say that electric field can be likely in the direction. Avladha. Okay va? So this is how we'll have questions, reasoning questions that can be asked on the concept of this potential gradient. Okay. Purida? So I hope you are able to Okay, next என்னது பாருங்க. So we have seen the idea of how do we understand the electric field component along a particular direction. But if you want to find the exact electric field value, so how do you find the exact electric field value? அதுக்கு என்ன தெரியுமா? So we'll use the same concept. இதுக்கு முன்னாடி நம்ம what is the concept that we have seen, right? அந்த concept அப்படியே நம்ம expand பண்ண போறோம். So என்னது பாருங்க, if we mark a point in space, அங்கிருந்து we'll try to calculate what is the component of the electric field along the x-axis. அதுக்கு என்னது, if you want to find the electric field component in any direction, what we should know, electric field component in any direction is equal to what? Negative of the potential gradient in the direction. அப்படிதானா? So we should calculate what is the negative of potential gradient in that particular direction. இங்க என்ன தெரியுமா, இந்த dr small change along that x-axis, இந்த dr க்கு பதிலா நம்ம என்ன எடுக்க போறோம்னா we'll use dx instead of using dr. What we are going to use, because it is along x-axis, right? So அதனால we will use dx. But இங்க என்னன்னா, when we use this dv by dx, normally in mathematics, right, we'll have it's a derivative function dana. So when we say dv by dx, it's a derivative function. But when we use this notation dv by dx, it is actually called as a total derivative or complete derivative. We call it as what? Total derivative or complete derivative. What do you mean by total derivative or complete derivative? So இப்போ பாருங்க, I'll just give you one sample mathematical function. இப்போ x v is equal to x square yz அப்படின்னு வச்சுக்கோங்க. Then when we want to calculate dv by dx, அதனது we have to take a derivative of the function, right? We have to take a derivative of the function with respect to x. So in the derivative நம்ம எடுக்கும்போது we'll use the idea that x is a variable, y is also variable, and the மாதிரி z is also variable. So when we are taking a derivative with respect to x, we'll use what? The idea that x is a variable, y is also variable, z is also variable. So அதனால என்ன, we'll use this u v z or the product rule. Maybe you might not be that much familiar with this, but அப்போ அந்த டெரிவேட்டிவ் நம்ம ஃபைனல் வேல்யூ நம்ம கால்குலேட் பண்றதுக்கு we will be requiring what? Product rule of derivative, because we will take each of the things as a variable. But here என்ன தெரியுமா, we are only interested in knowing how the potential or the value is changing. How the potential value is changing just due to the change in the value of x. We are not interested in knowing the change in the potential value because of the variable y or variable z. So இங்க என்ன நம்ம பார்க்கிறோம், we are only looking at what is the change in the potential value because of the change in the variable x. So அதுக்கு என்னன்னா, in mathematics, right, we will call it as a partial derivative. So what is the exact word that we'll use? Partial derivative. Partial derivative என்ன தெரியுமா? For that we'll use a different notation. Like d க்கு பதிலா we'll use this ஒரு curve d மாதிரி dou. Okay, so minus dv by dx அப்படி சொல்றதுக்கு பதிலா what is the way in which we will pronounce it? Minus dou v by dou x. இதுல ஒரே ஒரு டிஃபரன்ஸ் என்ன தெரியுமா, when we take this dv by dx, we have to consider y also as a variable, z also as a variable. But the partial derivative எடுக்கும்போது we will have to consider that வெறும் அந்த x மட்டும் is the variable part. Y and z we will have to consider them to be like a constants. இப்போ நான் ஒரு சாம்பிள் காமிக்கிறேன். Let's say இந்த ஃபங்க்ஷனை நீங்க எடுங்க. Okay, so if you want to take a partial derivative for this, இப்போ dou v by dou x value நமக்கு வேணும்னு வெச்சுக்கோங்க. So that will be what? We have to take a partial derivative of this x square yz. Partial derivative நம்ம எடுக்கும்போது we will take y as a constant, z also as a constant. So அப்படியே அந்த y and z values வெளியே வரும். So it will be like what? Derivative of x square. What is derivative of x square? இதோட வேல்யூ என்ன? 2x தானா? அவ்வளவுதான் டிஃபரன்ஸ். So normal derivative நம்ம எடுக்கும்போது என்னது, we will be having all x, y, z treated as the variables. But in the partial derivative concept lenna, if you are taking a partial derivative with respect to x, then only x is going to be treated as a variable. Matadella will be what? Constant. Y or z will be taken as a constant. Okay. So இப்போ இதுல இருந்து நமக்கு என்ன வரும், the component of the electric field along the x axis, அதோட வேல்யூ நம்ம எப்படி எக்ஸ்பிரஸ் பண்றது, minus dou v by dou x. Okay, so this is what this is giving us, negative of gradient along the potential gradient along the x axis. அந்த மாதிரி just we'll replicate it, அப்படியே நம்ம replicate பண்ணலாம். We want to find the component of the electric field along the y axis. அது என்னது, minus dou v by dou y. So we have to take the அங்க partial derivative with respect to y as the variable. அவ்வளவுதான். We want to know what is the electric field or the component along the z axis. அதுக்கு என்ன, minus dou v by dou z. So we'll have to take the partial derivatives. I'll show you one example so that you can follow this properly. So what is it? Partial derivative on sonna, we'll just have to consider on the variable தவிர மத்ததெல்லாம் will be taken as a constant. அவ்வளவுதான். Okay. So the same thing, right? I'll take the same example. இப்போ இங்க இந்த ஃபங்க்ஷன் எடுங்க. What is the function that we are considering? The potential is given as x square yz ன்னு வெச்சுக்கோங்க. What is the potential function given to us? X square yz. Okay. இப்போ என்ன தெரியுமா, we will try to calculate what is the electric field. We'll try to calculate what is the electric field. So electric field and sonna, we should know what is the x component value, y component value, z component value. What is this? Minus dou v by dou x. What is this? Minus dou v by dou y. What is this? Minus dou v by dou z. So இப்போ பாருங்க, first ex நம்ம calculate பண்ணலாம். What is it? Minus, we have to take a partial derivative of the function, potential function x square yz. இப்போ பாருங்க, partial derivative நம்ம எடுக்கும்போது y and z will be a constant. அப்படியே அந்த y and z வெளியே வரும். அந்த y and z values வெளியே நம்ம எடுத்துட்டு வரதுக்கு அப்புறம் it is like normal derivative மாதிரி தான். What is the derivative of x square? 2x. அவ்வளவுதான். So what is this? Minus 2xyz. That is our ex ஓட value. ஓகேவா? அதுக்கப்புறம் we will find ey. What is ey? Ey will be what? We have to take minus dou v by dou y. Okay. So இதை நம்ம கன்ஃபியூஸ் பண்ண வேண்டாம். It's a very, in fact, நம்ம நார்மல் டெரிவேட்டிவ் எடுக்கிறதுக்கு, I mean அந்த இதுல இருந்து it will be a little bit one step lower level only. It will be little bit easier. So இங்க பாருங்க, we have to take the electric field ஓட y component means what? Minus dou v by dou y தானா. So dou function என்ன, x square yz. இப்போ நம்ம partial derivative with respect to y பண்ணும்போது x will be taken as a constant, z also will be constant. அப்படியே அந்த ரெண்டு values வெளியே வரும். Minus x square z, derivative of y with respect to y is what? 1. So what is it? Minus x square z. That is our ey value. And the madri we can also calculate ez. What is it? Minus dou v by dou z. Paranga, we have to take partial derivative of that function. So idhula enna theriyuma, x will be a constant and the madri y will be a constant. Apadi and the rendu values veliye varum. They both will come out. Derivative of z with respect to z is what? 1. So which is what? Minus x square y. So idhula endu enna varudhu namakku? We are getting what is the ex value, ey value and the madri ez. So what is the total electric field function? Ex into I cap, ey into j cap, ez into k cap. So if you want to express the electric field function means what? It will be ex into I cap. Already namakku ex irukka. What is ex? Minus 2xyz plus ey into j cap. Ey enadhi? Minus x square z. And the value namakku irukka. So ey into j cap plus ez into k cap. So thanitaniya we have to get what is the ex oda value, ey value, ez value. Adella nama merge panna, we will get what? The total electric field. Okay. So this is what we will generally call as the gradient formula. What do we generally call it as? Gradient formula. So gradient formula na onnu kadiyadu. It's just like, we are going to use this relation between the electric field and potential. This relation is based upon what? Taking the partial derivatives. Okay, what is the relation based upon? Taking the partial derivatives. Ipo parunga, I will just finally write the gradient formula. So what is the gradient formula? The total electric field, right, will be what? Ex into, what is Ex means? Minus dou v by dou x into I cap. அதுக்கப்புறம் minus dou v by dou y into j cap. அதுக்கப்புறம் minus dou v by dou z into k cap. இதுதானா? So we'll take minus, அப்படியே காமன் எடுங்க minus. It is what? Dou v by dou x into I cap, dou v by dou y into j cap, dou v by dou z into k cap. So இந்த மாதிரி ஒரு expression என்ன தெரியுமா? We will actually call it as the total gradient of potential, or delta. What is the symbol? This is what? Delta. So this function, right, dou v by dou x into I cap plus dou v by dou y into j cap plus dou v by dou z into k cap. What is the thing that we'll say? Total gradient. It's an important thing in mathematics. Okay, but we'll just require the method to get the electric field function. So mathematically people also represent it like this, minus delta v and solute. So delta represents what? And the total gradient value. Total gradient means what? Dou v by dou x into I cap plus dou v by dou y into j cap plus dou v by dou z into k cap. We can also use the word total gradient. Okay, illana you can remember the normal formula. E bar is equal to what? Minus dou v by dou x is what? Ex. Minus dou v by dou y is what? Ey. And minus dou v by dou z is what? Ez. Appadi நம்ம remember பண்ணலாம். Okay, so இதிலிருந்து we can find out what is the electric field if potential function is given to us. Okay, in fact நீங்க past year questions la பாத்தீங்கன்னா at least I think past 20-25 years past year papers la we got 4 questions just based on this gradient formula. Okay, look at this one. This is the question that has come in 2009. Okay, and the electric potential at a point x comma y comma z is given by minus x square y அதுக்கப்புறம் minus xz cube plus 4. இதுதான் electric potential ஓட function. The electric field at the point is, அந்த இடத்துல they are asking what is the electric field? Straight. What is it? Electric field is equal to what? Minus dou v by dou x into I cap. இதுதானா? Minus dou v by dou y into j cap. அதுக்கப்புறம் minus dou v by dou z into k cap. So ஒன்னு நம்ம calculate பண்ணலாம். பாருங்க, minus, first we will try to calculate dou v by dou x. So what is it? X square y xz cube அப்புறம் 4. So இதில் when you taking the partial derivative, partial derivative இருக்கும்போது other than x everything will be a constant. அப்படிதானே? other than x everything will be a constant. இங்க பாருங்க, we will try to split this. split பண்ண என்ன ஆகும்? ஆல்ரெடி வெளியே நமக்கு மைனஸ் இருக்கா? we are straight away trying to calculate minus dou by dou x. okay, அதனால we are keeping a minus over here. இப்போ பாருங்க, we will split the terms. split பண்ண என்ன வரும்? minus into minus will be plus. first term என்னது? x square y. அந்த மாதிரி second term பாருங்க, minus into minus will be plus x z cube. third term minus into plus will be minus. so இதுல என்ன தெரியுமா? we are taking the partial derivative with respect to x, means y will be a constant. so அப்படியே அந்த y வெளியே வரும். y remaining என்னது? second term என்ன? z will be a constant. அப்படியே அந்த z cube வெளியே வரும். third term என்ன பாருங்க? derivative of constant. constant means what? 0. so இப்போ first term பாருங்க, derivative of x square is what? 2x. இதில் என்னது? derivative of x is what? 1 plus z cube வரும். so what is this? 2xy plus z cube. இதுதான் minus dou v by dou x value. இது என்னது? Minus dou v by dou x value, which means what is it? This is our ex, I component. So இந்த ஒரு value மட்டும் வச்சிட்டு we can just conclude the answer. எப்படி பாருங்க, you look at these four options, right? இதுல only option D ல மட்டும் look at the I component. I component is what? What is the I component? We got I component, right? அதோட value என்ன? 2xy plus z cube. வெறும் அந்த option D ல மட்டும் it is matching. Only in option D it is matching. பாருங்க, where எங்கேயும் we are not able to see it, right? Option A ல it is not there. It is some 2xy, அது கிடையாது. Option B ல it is some z cube, அது கிடையாது. Option C ல 2xy minus z cube வருது, அது கிடையாது. So what is the answer for this? Option D. So this is how sometimes, right, நம்ம மத்த அந்த minus dou v by dou y அந்த மாதிரி minus dou v by dou z அதெல்லாம் நம்ம calculate பண்ண தேவையில்லை, without even doing it, right? Because it is an MCQ type of examination, right? The quicker you are able to get the answer, the better it is for us. So sometimes when you have questions like this, we can conclude the answer without doing the all steps. Okay, so அந்த மாதிரி ஒரு possibility இருக்கும். So அதனால என்ன, whenever we are having questions like this, right? இப்போ நீங்க ஃபுல்லா சால்வ் பண்ணோம்னா it is going to take some time. இப்போ நம்ம என்ன பண்ணிருக்கோம், ஒரு காம்போனன்ட் மட்டும் சால்வ் பண்ணிருக்கோம். அந்த மாதிரி we have to solve for two more components. கண்டிப்பா அது டைம் எடுக்கும். But if there is a chance that we can conclude the answer without even doing the other two, that is going to save the time for us, right? So அந்த மாதிரி ஒரு possibilitiesல we should be able to make use of it. Okay, so இப்போ already நமக்கிட்ட ஆன்சர் வருது, என்னது? Option D. But we'll try to calculate the other components also. என்னது பாருங்க, minus dou v by dou y, which means what? Negative gradient with respect to y. xz cube plus 4. இதுலயும் அப்படிதான் தனித்தனியா நம்ம ஸ்ப்ளிட் பண்ணி எழுதலாம். So minus into minus is what? Plus. Minus into minus is what? Plus. அதுக்கப்புறம் minus into minus is what? Minus. இதுல நீங்க பாருங்க, third term, right? Derivative of a constant number is 0 தானா? Interesting என்னது தெரியுமா? Second term பாருங்க. Second term என்னது? The partial derivative with respect to y for xz cube. Now when the variable is y, x will be taken as a constant. And the மாதிரி z also will be taken as a constant. So because these two are constants, right? What is the derivative of a constant? 0. So அப்போ வெறும் அந்த first term மட்டும் will be remaining. இங்க பாருங்க, other than y everything is a constant. அப்படியே அந்த x square வெளியே வரும். Derivative of y with respect to y is what? 1, which means x square. So ey இதனது the j component. ey ஓட வேல்யூ என்ன? minus dou v by dou y, அதுதானா? So what is the value coming as? x square. இங்க பாருங்க, மேட்ச் ஆயிட்டு இருக்கா? So what is the j cap ஓட component? It is what? x square. அப்படியே we can calculate the k cap அதோட component also. So what is that? Minus dou v by dou z. Okay, so if you are able to understand this partial derivative concept, right, solving this particular type of question will be very easy. So last will be minus dou v by dou z. This is what is the ez oda value. So minus dou by dou z minus x square y minus xz cube plus 4. எங்கேயும் அப்படிதான் தனித்தனியா நம்ம ஸ்ப்ளிட் பண்ணி எழுதலாம். Minus into minus is what? Plus. Okay, அப்புறம் minus into minus is what? Plus. Last term will be minus. See, last term will be 0, derivative of constant. First term பாருங்க, we are taking the derivative, partial derivative with respect to z. அப்படி நம்ம எடுக்கும்போது x will be a constant for us, and the மாதிரி y will be also constant, right? So function குள்ள என்ன இருக்கு? x square y means the total term will be constant. Derivative of constant will be what? 0 தானா? So வெறும் அந்த second term மட்டும் will be remaining. So அதுல என்ன? we are taking the derivative with respect to z means x will be a constant. அப்படியே x வெளியே வரும், z cube. அந்த கான்ஸ்டன்ட் நம்ம வெளியே கொண்டு வரதுக்கு அப்புறம் it is like a normal derivative தான். So what is derivative of z cube? அதானது 3z square தானா. What is the derivative of z cube? It is what? 3z square. So what is it? 3xz square. அவ்வளவுதான். So what is the k component value? 3xz square. பாருங்க, that is what we have in the option D. But இதெல்லாம் இந்த y component அந்த மாதிரி z component நம்ம calculate பண்ண தேவையில்லை, because if you are confident about our x component itself, right, அப்படியே நம்ம ஆன்சர் கன்க்ளூட் பண்ணிட்டு போலாம். Okay, so next this is a question that has come in 2015. நான் சொன்ன மாதிரி I have not taken all the 4 questions, I have taken 2 questions. So this is the question in 2015. பாருங்க, if potential in volt in a region is expressed as, என்ன கொடுத்திருக்காங்க, they are giving us the potential function. ஒரே format தான், they will give us the potential function. அதுக்கப்புறம் they will ask us to find the electric field. இதுல ஒரே difference என்ன தெரியுமா, they are asking us the electric field at 1,1,0 point. So எப்படி இது சால்வ் பண்றது? First we will get the electric field. எப்படி? By using that gradient formula, minus dou v by dou x into I cap minus dou v by dou y into j cap minus dou v by dou z into k cap. நீங்க ட்ரை பண்ணி பாருங்க, நான் வெயிட் பண்றேன். So we'll get the electric field function. அந்த electric field function வந்ததுக்கு அப்புறம் we will substitute the points. So பாத்தீங்கன்னா the electric field function is going to come in terms of x y z. the variable formula தான் வரும். அந்த function வந்ததுக்கு அப்புறம் ஃபங்க்ஷனுக்குள்ள we will substitute x is equal to 1, y is equal to 1, z is equal to 0. substitute பண்ணா we will get the final answer. First நம்ம என்ன பண்ணணும், we should calculate what is the electric field function by using the gradient formula. Okay, அந்த electric field function வந்ததுக்கு அப்புறம் we will be able to அப்படியே x value, y value, z value substitute பண்ணா அதுல இருந்து we will get what is the final answer. நீங்க செக் பண்ணி பாருங்க. சில ஒன்று நம்ம போலாம். What is it? First we will try to tackle this x component minus function என்னது 6xy minus y plus 2yz. split பண்ணி நம்ம எழுதுறோம். What is it? 6xy y okay. So இதெல்லாம் பாருங்க, we are taking the partial derivative with respect to x தானா, which means y will be a constant. அந்த மாதிரி இதுலயும் yz also will be a constant. அப்படியே அந்த second term third term 0 ஆயிடும். வெறும் first term மட்டும் will be remaining. Will be having only first term. Okay, so first term என்னது பாருங்க, 6 is anyway constant. அந்த மாதிரி y will be also constant. ஏன்னா we are taking the partial derivative with respect to x. So அதனால என்னது minus 6y, வெறும் அந்த x மட்டும் will be remaining inside. What is the derivative of x1? Which is minus 6y. So the x component value என்னது minus 6y. Okay, so பாருங்க, I am writing the function here minus 6y into I cap. இதுல தெரியுமா, because if you are solving this in the final examination, we should always see how quickly we can get to the answer. எவ்வளவு குவிக்கா நம்ம ஆன்சர் எடை பண்ண முடியும் அதுதான் நம்ம பார்க்கணும். See, the moment I get the x component right, அப்படி என்ன தெரியுமா, I will think about it. So இதுல நமக்கு x component வேணும்னு வெச்சுக்கோங்க, I need to substitute the value of y தானா. y ஓட வேல்யூ என்ன 1, இங்க சப்ஸ்டிட்யூட் பண்ண என்ன வரும் minus 6i. So the x component or y component will be what, minus 6. The x component or the I component will be what, minus 6. நீங்க பாருங்க இருக்கிற ஆப்ஷன்ஸ்ல ஆப்ஷன் ஏவும் கிடையாது. So like that I can eliminate. Option C கிடையாது. ஏன்னா look at this, right, here it is minus 2, here it is minus 3. So our option is going to be only between B and D. Our option is going to be only between B and D. அப்படிதானா. Next என்ன தெரியுமா, we will go to the second one. அதுலேருந்து we can conclude the answer. நான் காமிக்கிறேன். So we don't need to even calculate the z component. அது நம்ம பண்ண தேவையில்லை. If you are able to get the second one right, from there we can conclude the answer. எப்படி பாருங்க, if you are able to calculate the y component, that is what minus dou v by dou y dana, which is what function is 6xy minus y plus 2yz. 6xy plus minus, so idhula parunga first term enadhi, we are taking the partial derivative with respect to y, adanaala 6 will be a constant, x will be a constant. So na inga eludra, so minus 6x, okay, adukaprom second term enadhu parunga, derivative of y with respect to y, which is what 1. Third term la irukka 2 is a constant, and madri z will be a constant, appadi and rendu values veliye varum, minus 2z. So derivative of y is 1, and madri inge derivative of y is 1. What is it? Minus 6x plus 1 minus 2z. What is it? Minus 6x plus 1 minus 2z. inga parunga, so idhula enna, we have to substitute the value of x is equal to 1, y idhula illa, okay, z will be 0. neenga appadiye substitute panni parunga, x is 1, right? So minus 6 plus 1, z is 0. So what is this? Minus 6 plus 1 means what? Minus 5. Okay, so ey oda value enna minus 5. So minus 5 j cap. So minus 6 I cap. Adukapram what is the ey value? Minus 5 j cap. We are able to conclude the answer from now, right? What is it? It cannot be option B. Why? Because x component is minus 6, y component is minus 5 only in our option D. So which means what is the correct answer? It will be option D. When we can check the third component also. Adi nama check panla, because we are doing the practice, right? Practice session irukadanaala we can just try the other one also. Purida? So but if you are solving the same thing in the final examination, means this is how you have to skip the steps. Appada namakku time save agum, adulundu we will be able to make sure that we are able to answer. Or sila students can now they will feel that physics la they are not able to attempt all the problems because the time is not sufficient. Appadi nu solittu there will be a usual complaint, and that can be avoided if you are able to take some steps like this. Ippadi neenga panna you will be able to save some time. So paranga we will try to, so if you are in the final examination, means that's it, you will not do the third one, adoda you will go on to the next question. But if you are practicing and you want to check the last component also, right? Adepadi ez value will be equal to what? Minus dou v by dou z paranga, which is what? Minus 6xy minus y plus 2yz. அப்படி நம்ம ஸ்ப்ளிட் பண்ணி எழுதலாம். 6xy y 2yz. இதுல first term பாருங்க, inside the function is what? 6xy. We are taking the partial derivative with respect to z, means for us any number will be a constant, and madri x also will take as constant, y also will take it as constant, appadidana, which means the entire function inside is a constant, adanal the derivative will be 0. And madri second term paranga, second term is what? Partial derivative of y with respect to z. When you take a partial derivative with respect to z, right, we will take y as a constant, so that is also 0. So where we will have the last term or third term alone. Inga paranga 2 will be taken out, appadiye y also will be taken out. So minus 2y into partial derivative of the z with respect to z. Idanadi 1, which means the ez oda value will be what? Minus 2y. We want to know what is the value of the electric field at 1, 1, 0 point, right? Which means y க்கு பதிலா நம்ம என்ன சப்ஸ்டிட்யூட் பண்ணனும் 1 சப்ஸ்டிட்யூட் பண்ணா என்ன வரும் -2 which means what பாருங்க அப்படியே -6i cap -5j cap -2k cap அப்படியே அந்த மைனஸ் நம்ம வெளியே கொண்டு வந்தா what is it minus of 6i plus 5j plus 2k அப்படி so that's how we'll get the electric field whenever a electric potential function is given. So idukku what is this approach called as gradient formula. So onnilla we'll just have to take the partial derivative functions but minus irukka. So e bar will be equal to what minus dou v by dou x into I cap. d and சொல்றதுக்கு பதிலா we'll use the word dou. Okay, dou minus dou v by dou x into I cap அப்புறம் minus dou v by dou y into j cap and minus dou v by dou z into k cap. Okay va. So this is what is the method to find electric field when potential function is given to us. So நீங்க questions பார்த்தா if you are clear with this concept, right, you will be able to answer those questions. அப்படிதான் வரும். இதுக்கு மேல there will be no application involved. அப்படியே அந்த gradient formula எடுத்துட்டு substitute பண்ண மாதிரி தான் வரும் questions. Okay, now if the potential function is given to us, adulundu we have seen how to get the field using the gradient formula. But ipo enna theriyuma, we are going to see the reverse. If the electric field is known to us, like they are giving us the electric field function kudutha, adulundu we will be able to calculate what is the potential difference between 2 points. Anyway, we will be able to calculate what is the potential difference between 2 points when electric field is given to us. அது எப்படின்னு சொல்லிட்டு we will just look at it. Okay, so அதுக்கு என்ன தெரியுமா, we will go back to the initial, நம்ம இனி originally நம்ம அந்த discussion start பண்ணிருக்கோம். இதுல இருந்து we have taken a point and at this point we are taking a very small displacement. We are taking a very small displacement. Okay, and the corresponding potential difference we are calling as what dV. The corresponding potential difference we are calling as what dV dana. So what is the relation we had between electric field and the potential difference? Remember, we have taken the charge, so the work done by the electrostatic force, what is it? Force dot displacement vector. Negative of this is equal to change in the potential energy, which means what? Q dV. What is change in potential energy? Q times dV, because when a particle is moving from the initial position to the final position, this is the initial position, this is the final position. Okay, what is the change in potential energy? It will be what? Charge times the potential difference. So then the q cancel out, which means minus E dot dr will be equal to dV. The small change in potential or the small potential difference value will be equal to what? Minus E bar dot dr bar. So if we integrate it on both sides such that we will move from the initial position to the final position, we are doing the integration from initial point to final point. In the bakana we will do the integration from the initial point, let us say point A, adha madri final point, point B. So left hand side enna varum, we will have to do this integration. So what is this? Integral minus E dot dr. Integral minus E dot dr. Integration limits will be what? Initial point to final points. அப்படி பண்ணா right hand side என்னது பாருங்க, integral of dV means what? Potential தானா? Integral dV means what? Potential between the limits initial and final, which means what? V final minus V initial. That is what we call as the potential difference. So if you want to find potential difference between 2 points when electric field function is given to us, adhu can approach, we have to take that integration. Okay, potential landu we want to get the electric field means derivative, partial derivative. But in the integration, so if you are doing minus integral E dot dr, the potential difference between the initial point and the final point. Okay, but this concept, right, is not being asked. In the past years, they have not touched upon this particular idea. You have got questions on the gradient formula, but this base panni varala. Maybe you can have a chance of getting questions on this in the future examinations. Okay, focus it's a simple idea only. We should just integrate minus integral E dot dr. We'll get what? We'll get what is the potential difference between the initial point and the final point. We'll look at a problem. Okay, so find the potential difference VAB between the point A point or coordinates. What is it? 2 meter, 1 meter, 0. And point B. What are the coordinates of the point B? 0, 2 meter, 4 meter. We should calculate the potential difference VAB. Means what? Potential difference VAB means what? VB minus VA dana. We should calculate VB minus VA. They are giving us the electric field function. Electric field function kuduthirukanga. What is it? E bar is equal to what? Xi minus 2yj adukaprom zk. Everything is in the SI system of unit. So this is in what? Volt per meter, and also the coordinates are in terms of meter, means everything is in the SI system. Now look at this formula we have. Minus integral E dot dr is equal to the change in potential. Here we have to integrate from point A to point B. The initial point is point A and final point is point B. Now in the value we simplify minus integral E dot dr. This simplify first we should express the dr vector. Dr enna theriyuma? The differential displacement vector. For any small displacement along the x component dx, small displacement along the y component dy, small displacement along the z component dz. So the small displacement vector will be represented by what? Dx into I plus dy into j plus dz into k. So what is this? Dr bar will be what? Small displacement vector will be represented as what? Dx into I plus dy into j plus dz into k. It's a standard representation. Whenever we want to represent the small change in the position, that will be given by what? This differentially small displacement vector. Represent it is what? Dx into I cap, small change in the x coordinate into I cap, plus small change in the y component dy into j cap, plus small change in the z component dz into k cap. Okay, so on the integration E dot dr dana. So in the two vectors dot product nam edukano. How do you take the dot product of two vectors? Product of the I components idil x, idil the dx, which means what? X into dx, plus product of the j components. In the j component another minus 2y. Here it is what? Dy, which is what? Minus 2y dy, plus product of the k components. In another z. Here it is what? Dz. So this is what is E dot dr value. This is what is E dot dr. Okay, so we should just substitute in that and the integration formula substitute panna. So what is it? And the integration formula substitute panna enna varum parunga. Substitute panna enna varum? Minus integral A to B and solve badala, we will try to represent this in terms of the actual coordinates. A means what? 2, 1, 0. B means what? 0, 2, 4. What is E dot dr means? X dx minus 2y dy plus z dz. So we should, this is what is our delta v. These are our delta v. Okay, so we should split this integration. here the variable is x, here the variable is y, here the variable is z. அப்ப நம்ம என்ன பண்ணணும், அப்படியே அந்த இன்டிகிரேஷன் ஸ்ப்ளிட் பண்ணணும். ஸ்ப்ளிட் பண்ணா we should be careful. வெளியே என்ன இருக்கா, we have a negative there, அது நம்ம கேர்ஃபுல்லா இருக்கணும். we have a minus outside. ஓகே, பாருங்க ஸ்ப்ளிட் பண்ண என்ன வரும், minus x dx வரும் plus integral 2y dy, ஏன்னா minus into minus becomes plus, அதுக்கப்புறம் minus integral z dz. இதுல என்ன தெரியுமா, the first integration is having the variable x. so இங்க limits என்ன வரும், x limits. what are the x limits? initial limit of the x is 2, final limit value என்ன 0. இங்க பாருங்க y ஓட limits, second term is having variable as y. y limits என்ன, initial limit is 1, final limit is 2. அந்த மாதிரி நீங்க z limits பாருங்க, initial limit is 0, final limit is 4. okay, so என்ன வரும், x dx. x dx means what, integral x dx is what, x square by 2 தானா, which means minus அப்படியே வெளியே இருக்கும், x square by 2. limits are what, initial limit is 2, final limit is 0. இது என்னது பாருங்க, 2y dy. integrate பண்ண என்ன வரும், y square. y square limits are what, 1 to 2. அதுக்கப்புறம் z dz. இது என்னது, z square by 2, which is minus z square by 2. limits என்ன 0 to 4. so இப்போ நம்ம இந்த final limit initial limits அதோட simplify பண்ணணும், அவ்வளவுதான். பண்ணா we'll get the answer. பாருங்க, so first term என்ன இருக்கா, minus is there, x square by 2 limits நம்ம substitute பண்ணணும். final limit is 0, so minus 0 square by 2 minus 2 square by 2. okay, so which is what, 0 means 0 only, 2 square means what, 4, right, 1 2 will get cancelled, minus into minus becomes what, plus. okay, second term பாருங்க, y square limits are what, 1 to 2, which is 2 square minus 1 square, which is what, 4 minus 1, that is 3. அதுக்கப்புறம் last term பாருங்க, minus z square by 2, limits are 0 to 4, which means 4 square by 2 minus 0 square by 2. இதுல 0 square means 0 only, 4 square means what, 16 தானா, so 16 by 2 is what, 8. so இங்க என்ன வரும், minus 8 வரும். இங்க என்ன வரும், it will get minus 8. okay, so இப்போ பாருங்க, what do we have as the total potential difference? இந்த மூணு term நம்ம அப்படியே ஆட் பண்ணணும். what is it, 2 plus 3 minus 8, what is it, minus 3 வரும் volt. what is the potential difference, VAB oda value, it will be what, minus 3. புரியுதா? so this is the model of question that has not been asked. previous years la பாத்தீங்கன்னா they have not asked, but they have asked the other side of it. என்னது, potential function ல இருந்து எப்படி, how do we get the electric field, அந்த மாதிரி questions they have asked. but இந்த side அவங்களுக்கு கேட்கல, they have not asked questions on finding the potential difference by using the electric field function. அதுக்கு என்ன, we'll have the integration formula, minus integral E dot dr will be equal to what, simply the potential difference between the initial point and the final point, delta V. okay, இதுல dr எப்படி நம்ம எக்ஸ்பிரஸ் பண்றது, dr will be what, dx into I plus dy into j plus dz into k. அப்படிதான் நம்ம small displacement vector represent பண்ண போறோம். okay, so this is about the way in which we will use the relation between the electric field and potential. next class la we'll start with the idea of equipotential surface, and then we'll get into the other aspects of electric potential. okay, so we'll see in the next class.